Hello, this is my water quality and filtration science fair project. The question was, what water sources are safe to drink, and will filtration help remove bacteria and other contaminants from the water? The purpose of this project is to test various water sources and to get the result to determine what water sources are safe to drink. I am using a water filtration system to determine the results of the quality of water both before and after filtration. The goal is to find a way to make sure that the water we drink is safe, and to make sure that we can come up with solutions for how to get safe drinking water to those in desperate need around the world who do not have access to safe drinking water. The water sources I tested were from my house tap water, lake water, school water, and Zephyrhills bottled water. I checked for contaminants such as bacteria, lead, pesticide, chlorine, copper, alkalinity, pH levels, hardness, nitrate, and nitrite. I will then be filtering the same different water sources and testing to see if there are any changes after filtration. The societal impact of the project is water filtration and how it has a big impact on many human beings because unfiltered water can lead to stomach problems and even death. With a water filtration system, it can remove all types of harmful things. Imagine what water filtration can do for the world. Why water filtration is important, you may ask. Clean water is critical and there's a major shortage. Our bodies are mostly made of water and we need clean water to survive. A fun fact is nearly 1 in 5 children worldwide lack access to clean water. Water filtration gives people access to clean water and has no contaminants or bacteria in it. Some water crisis facts are more people die from unsafe water than all forms of violence, even including war. 2 billion, or about 1 in 4, lack access to a clean toilet. Diarrheal disease kills a child every 60 seconds. And 784 million people around the world are without basic water access. That's more than twice the population of the United States. My initial hypothesis was that if water containing bacteria and sediment and many other contaminants goes through the water filter, then the water will be clearer and cleaner and safer to drink after filtration. The independent variable is the water that is being filtered, and the dependent is the water that is not being filtered. The constant group is the water that is staying the same, and the control group is the water that is being filtered. The materials needed are a pure test home water analysis kit, a clear plastic cup, empty clear plastic cups for water bottle with a cap, 1 bottle of Zephyrhills water brought at the store, a Story Mini water filtration system, a pencil and paper to record your results, a watch or a timer for keeping track of elapsed time when recording the results. A pure test home water analysis kit includes 1 test for each bacteria, 1 test for each lead and pesticide, 2 tests for each iron test, chlorine, copper, nitrate, alkalinity, pH, and hardness. 1 plastic test vial with lid for use of litmus paper. 1 glass test vial for storing and testing bacteria. As you can see on the right, those are the materials that I just said. Step 1 would be to use a clear plastic cup to take samples of the water to be tested before filtration. Note: use the empty clear plastic water bottle cap with 16 fluid ounces to take school sample so you can transport this without spilling. You will be testing 4 different sources of water: home water, lake water, school water, and store-bought water. Step 2 is run the Pure Test Home Water Analysis Kit on your water samples. Do the same test 4 times. Each test is for different water sources listed in Step 1. Be sure to follow different timetables when testing the water with the kit. The bacteria test requires 48 hours before recording your results. Step 3. Record your results for the Pure Test Home Water Analysis Kit on a white lined sheet of paper. Be sure to record all results for each different water supply on a separate sheet of paper. Also be sure to label each set of results. Step 4. We will now be repeating our steps above, only this time we will be filtering the water. Step 5. Get your tap, bottled water, lake water, and school water and run it through a Story Mini water filtration system at least one time. Record your results for a different water source after filtration and be sure to label them. Example, lake water after filtration. Step 7 is to compare and contrast the data from the water looking at each source individually. The data results are that, as you can see, the lake water and surface water, as you can see, lake water being on the left and surface being on the right. I tested both for chlorine, copper, nitrate, alkalinity, hardness, and iron. I tested for all of those, and I tested for ppm, parts per million, as you can see in the graphs, both for lake water and surface. And now, as you can see, house tap water and school water being on the right and house water being on the left. I again tested for chlorine, copper, nitrate, alkalinity, hardness, and iron. And on the graphs, again, you can see the data. I also filtered for pH levels for the lake water, house water, school water, and surface bottled water. I tested to see for the pH levels on the graph below. I also tested for lead, pesticide, and bacteria. For the house water, school water, and surface bottled water, they were all negative, except for the lake water and bacteria. There was shown to be E. coli and bacteria present in the lake water, but after filtration, there was none present in the lake water. The key to understanding all of this, you may ask, is that when I got my data, I did not know what ppm stands for, or the data, so I tested for chlorine, copper, nitrate, alkalinity, pH, hardness, iron, lead, pesticide, and bacteria. I tested for the axon levels and to see what they did. As you can see on the right, the litmus paper for chlorine, copper, nitrate, and alkalinity, pH, hardness, iron, lead, and pesticide. It tells you what each of them means, and it tells you the axon levels to take action and what they are safe to drink. The entire conclusion is stated in my abstract. The purpose of this project was to gather information on local drinking water sources and to check for the contaminants such as bacteria, lead, chlorine, copper, pH levels, iron, etc. Water was collected and tested before and after filtration process to determine if there were any changes. A total of 4 water sources were sampled. 8 samples in total were collected, 2 from each source. Each sample was tested before filtration using the PureTest home water analysis kit, and the samples were filtered through a Story Mini water filtration system and tested again 3 times. It was then held level for 2 seconds, and the colors were compared to a chart to determine the parts per million, which you know as ppm. This process was repeated for all sources. The data collected shows favorably that the water which has been filtered is cleaner than the water that is not. The house, school, and bottled water all had similar results. The lake water had different results. The lake water was cleaner after filtration, and the test results proved bacteria was removed. This experiment was important to educate people on water quality and to show how people can access clean and safe drinking water worldwide.